Um, but yeah, let's go ahead and get started. What I'm going to do today is I'm going to run through Unity usage specifically. Hey, what's going on, Zehastu? Is that how you say that? Zehastu? Zehastu? Probably Zehastu, right? I'm going to run through the basics of using Unity, and I'm going to come at it with the expectation that this would be like your first introduction to any sort of coding or game design element. And if people are like, yo, just get going, we already know this stuff, then I'll kind of speed it up from there. But I want to make sure that we're all on the same page. So what this is Unity 2018. I am a version behind, but it is functionally identical to any Unity that you're going to download offline for the basic use cases. What are all these windows? We will, for right now, if you don't know what all of these are, don't worry about it. We're going to go over each one of them a little bit more in detail as we go along. But just keep in mind that these different windows are kind of like their own entities of sorts. So if I was going to select something down here, it doesn't like cover over anything up here or anything like that. It all stays down in that window specifically. The main thing that drives most games are these two windows here, the scene window and the game window. And you'll notice that they kind of look functionally the same, but this one has a little bit more to it. So what's the difference here? Well, this is what your player is going to see, and this is what's you're going to see, essentially. This is how you're going to make what the player is going to see. That's the scene, that's your workspace, and then the game is the player's workspace, if you kind of want to think of it that way. So if I was going to, say, add something over here, and I'll explain what this is in a second, but if I was going to add something over here, you'll see that it appears on both windows, but it kind of looks different, right? Like I can move this window around and it doesn't really affect what's up here. And that's because, again, this is what the player is seeing, but this is what you are able to work with and, you know, make happen. So if I was to move this around, it'll move up here as well. And yeah, that's the general idea. Two windows, one is for the player, one is for you, the person making the game. So why is it that I'm able to see this cube? Because I put a cube down, but I didn't really tell the computer that it should be able to see the cube. Well, it turns out in Unity specifically, and also a lot of other engines, when you create a scene for the first time, it'll usually have a couple of default things placed in that scene. In this case, we've got a light, which we can choose to have or not. It doesn't really matter too much. And then we have a camera. And I'm sure what you could imagine is that this camera is exactly what the player is seeing. So pretty much this guy is going to be taking information and shooting it up to this screen here. I mean, that seems kind of obvious, but then you get into some really weird situations where you've got more than one camera. You can kind of see that I have multiple selected, and then how on earth is Unity going to deal with that, and you know, stuff, but we'll get into that in a little while. So what is this? Well, we've got three different things up here. The camera, which I already talked about, the light, which I already talked about, and then the cube that I just placed in. Not too much of a stretch to figure out that that has everything to do with the objects that are going to be placed in your scenes, like the things that your game is going to be made out of. And that's exactly what it is. So if I was going to come up here and say create a sphere, that's suddenly going to be inside of my game permanently. Like that's just a piece of the game until, of course, I delete it and then it's not there anymore. Why do we need this window? Why can't we just select things down here? The reason is it's just easier to find them when they're in a list, and that's pretty much as simple as it is. I can select things down here. If I wanted to select the cube, I can click on it and you'll see that it selects up here as well. But if you've got like several thousand objects that span, you know, this much distance and everything like that, having them in a list is really, really helpful. So that's usually what you want to use this for. You might notice when I select something over there, we get some information over here, which looks maybe a little bit scary if you've never seen something like this before. but it's actually pretty simple. So let me go ahead and actually delete my cube and create what's called an empty game object and just name it to show the peepers, which is you. So that, I mean, that's obviously a lot less complicated than what the cube had. But what are these? What is here? What does it mean? So don't. One thing that's going to come up a lot is don't get caught up too much on the terminology of things. Usually, if you think something is doing something, it is probably to a degree or so. In this case, we've got a bunch of numbers that say position, we've got a bunch of numbers that say rotation, and we've got a bunch of numbers that say scale. And that's pretty much exactly what it sounds like it is. It's where your object is located in your game, what rotation your object is at in your game, and how large your object is at in your game. So right now, I can move it around, and you can kind of see that my little handlebars are moving around. But man, it doesn't really look like much, does it? In fact, the more I zoom in on this guy, the more you'll see there's just really nothing there. In fact, now I've zoomed in to the point where I'm actually past the object in the game. So what's going on with that? Why aren't I able to see anything? And the simple answer is because I haven't told it to see anything. I created an empty game object, and that empty game object just has a position. It doesn't have any sort of visual element to it or anything else. It's just kind of there in negative space. So if we wanted it to show something in our game, we'd have to tell it that it needed to show something, is kind of the point here. Just for the ease of access, I'm just going to go ahead and create a cube again. And you can see that those numbers are still up there, that position and rotation and everything like that, and I can still adjust those just like I did before. But we've also got some other things here, and the difference is now we're also able to see something on the screen. Well, you know, these things are doing exactly that. If I was to turn this one off particularly, you'll see that the cube kind of comes in and out as I turn it in and off. So we know that that's what's actually showing our cube. And then we've got something down here, and I won't talk about that quite yet. I'll talk about that in a little bit. Okay, so that's the very basics of using the Unity editor as a whole. What I want to do next is I want to show you how you would be able to create things that move or do something in your game or something along those lines. So going back over here, let's just show the difference between those two things again. We've got one that's displaying a cube and one that's not really doing much of anything, right? Those are two different objects inside of our game. So this guy has these extra little nodes. You can see that they're being demarked by these lines inside of this thing called the inspector over here. So what exactly are those? Well, they're called components. And what a component is it's a thing that does a thing. And I know that's like a super wide definition of it, but that's really all it is. They can do anything from giving your cube gravity. It could be something that throws your cube out into the nether space. It could be something that squashes your cube. It doesn't really matter what it is, because components are just whatever you really make of them. So in this case, we've got a component that's rendering the cube, and we've got this component that's that says that it's a box collider. And again, I'll get to that in a little bit here. And then I've also got this button where I can add new ones. So say I wanted this thing to have some animation, I could put an animator on it. If I wanted it to have physics, I could put what's called a rigid body on it. I'll get more into that in a little bit too. And so on and so on and so on. The important one is, well, not the only important one, but the most important one is this one called new script. Well, this is never really a button that you should push, and I'll show you why in a second, but I'm going to go ahead and push it, and I'm just going to call it cube script. So here, as soon as this pops up, here's a component, and it just doesn't really have any data to it. Like, you know, this has stuff, this has stuff, even that has a little bit of stuff, but this has nothing. And the reason for that is this is going to be something that I make myself. Yeah, new script, right? You kind of never want to push the new script button solely for the reason that inside of like the assets in your game, it's always going to just shove it in the bottom most directory of your assets, which seems really good when you're starting doing game development, but then as you go along, you kind of realize, oh wait, maybe I just want to take that thing and I just want to drag it into a folder named scripts or something like that, just so I know where it is forevermore. But anyway, so this is a component that I'm going to make myself. It's not something that Unity has already defined, like these guys over here. It's something that I'm going to tell it what it's going to do. So let's go ahead and do that real quick and just do something really simple. By the way, if you've never done this before, this is exactly where the coding part of game development is going to come in. It's exactly in these script sort of things. So I named it CubeScript. You can see that down here. So I'm going to go find CubeScript in the scripts folder, which is where I placed it, and I'm going to double click on that, and it's going to bring up a window that looks something like this. So this is another really good example of don't get caught up in the terminology. Just kind of try to understand what you can, and as you go along, you're going to understand more and more of it. So you can ignore all that for right now, but you can see, oh, well, CubeScript, that means we're in the right place. Okay. And then we've got these things that are kind of being encapsulated by curly brackets, which is interesting. And they've got this weird word void next to them. And then words that you'll recognize automatically, start and update. So what are these? Well, these are called functions, and you don't need to know that word. You just kind of need to understand what they'll do for you. If I was to write any code right in here, Unity is going to run that code automatically for me. Why is that? Don't worry about it. It just will. And I'll tell you why sometime down the road. But for right now, all you need to know is that it'll run the code. In fact, it'll run the code exactly once. It'll run the code when the game starts. That's not quite true, but for now, that's all you need to really think of it as. So I'm just going to adjust this little descriptor tag just to make it easy to parse for you guys. So start is called once when the game starts. So if I was to put any code right here, that code would run once when the game starts. Alternatively, here's another one. Update is called once per frame. Well, you can kind of imagine that if this is being called once, then this is probably going to be called more than once, right? Because we need some of that both ways. Like if we say needed to move something every frame of the game, well, we've got a function to do that. So if you know how people refer to frames per second of a video game or anything like that, like, oh my gosh, I'm maxing out at 144 frames per second, or anything along those lines, then you can kind of imagine that each one of those frames, the computer is coming in and it's finding all the code it's supposed to run, it's running it, and then it goes on to the next frame and it does that thing again. And by the way, this is exactly the function that you would put stuff in to have the computer do that. So if I wanted to, say, move my character every frame of the game, this is where I would do it. So how do I know what I'm supposed to write, though? Seems kind of nebulous. Shouldn't be update per tick? Really good question. So tick and frames are not really the same thing. Tick is something that is like more specific to a system that someone else has programmed. Minecraft is obviously the perfect example of ticks. But frames are just like the underlying terminology for, hey, my game has finished doing everything it needs to do and it wants to do more. Let's increment the frame, and now we're in a new frame. Ticks can be totally different from that. They can be all over the place. So it kind of means something different inherently. So in this case, it's very distinctively, this will be called every frame. And if you wanted to have it be called every tick, then you're going to need to tell the computer what a tick is, if that kind of makes sense. So let's go ahead and just kind of do something so you can see something happen. There's a neat little thing called print, and all it does is it just prints some bit of text to the console. And I'll show you exactly where you can find that. So I'm going to print, hey you did it. And notice I put that there. Don't worry about that. I'll explain that in a second. What are these parentheses? That's another thing that I'll explain a little bit. But just so you can see, hey, in that thing that I said was going to be called once at the start of the game, I put something that is going to print something to something else. Very, very nebulous, but just kind of keep that in mind, and I'll show you exactly what that will do. So if I go back to Unity here, now remember I put that script on my cube here. So if I was to go ahead and press the play button up here and run my game, you can see down here some text. Oh, maybe you can't actually. That's being cut off. Hold on. Just gonna move this a little bit. Here, I can show you in this window here. Much better. So you can see right here, I have a little bit of text that says, hey you did it. So how did that work? Unity came in, it saw that I had this component down here. Let me turn this off so you can see it. It saw that I had this component down here that was called CubeScript, and inside of CubeScript it saw that transitioning over to code, please. It saw that it was supposed to do this at the start of the game. And that's exactly what it did. When I pressed the play button, it went ahead and showed me that message, hey you did it. So if we're going to do something a little bit different, what I might try doing is, instead of just printing that once at the start of the game, maybe I'll see what happens if I put it in this function that I said was going to be called every frame of the game. Let's see what that does now. So if I go ahead and play this, and I won't have it maximize the screen so you can see this, now you can see I'm getting a lot of those messages. In fact, if you can see that number right there, we're already at like 400 of those messages. And it's just going to keep doing that and doing that and doing that ad infinitum until I stop the program, which I'm going to do right now. So that's kind of the difference between those two functions there. And now I'm going to kind of show you guys, fixed update is more per tick, right? Since it's based on a fixed time between frames rather than an update where the frames are inconsistent. Yeah, actually, that's a really good point. I guess you could kind of construe it that way. So fixed update, just to kind of jump ahead a little bit, it's a very similar sort of a thing. It also gets called regularly. But I guess how do I explain this simply? Fixed update gets called in equal spaces. So like, let's just say, for instance, those equal spaces were such that it would get called exactly 60 times every single second. Which it might not be, which that might not be like, that might not make sense right off the bat, but it has to do with how physics works in Unity. Yeah, essentially though, you could kind of call this a tick. That's a really good point. I didn't think of that. But we'll get to that in a little bit here. Let me just grab a drink here. Okay. So we've got a cube. That cube is shouting at us to do things. You might have also seen, and this was accidental, but kind of works perfectly. When I run the game here, sorry, let me do that again. When I run the game here, that cube starts on the screen and it is out really quickly. It wants nothing to do with this. So why is it doing that? Because I said, you know, if something is going to happen, you have to tell the computer for it to happen. Well, I kind of did. You just might have not noticed it. Let me go ahead and show you what would happen if I ran the game without this thing called rigid body over here. So I'm just going to remove that component from this cube over here. And if I go ahead and play the game now, you'll see that the cube doesn't move at all, which is actually kind of interesting. Counter to how people kind of often think about this, objects in video games don't move unless you tell them to move. Just like everything else, they won't show themselves unless you tell them to show a cube or whatever else you're trying to show, and they won't move unless you tell them that they're supposed to move. Yeah, rigid body physics, right? It's so much easier to start with that than like, oh my gosh, you can code your own movement. So we're going to start there. So what is a rigid body? Well, I'll tell you what it isn't. It sure as heck isn't a soft body. And that sounds really stupid, but that's about the best definition you can give it. It's something that will move. It has physics associated with it, but it's not going to like be affected by the wind like a cloth would. It's not going to be super squishy, so if you had an object fly into it, it's not going to compress. It's always going to retain exactly the form that it has when it starts. That's why it's called rigid. You know, it's hard, steely. What you drinking, thirsty boy? Wouldn't you like to know? No, it's water. It's water in an incredibly derpy Frosty the Snowman cup. But I don't usually admit that. Why am I drinking out of a Frosty the Snowman cup? Super simple. It's what I had on my desk at the time. A man of taste, I see. Yeah. Dude, so real quick aside, the water at my apartment tastes just like a little bit weird. Just like a tiny, tiny bit. So sometimes I like sprinkle in some lemon juice or something like that, just to make it better. But yeah, Frosty the Snowman cup. Yeah, I'll show you guys sometime. Anyhow, rigid bodies, right. This cup that I am drinking out of, that would be a rigid body. The water inside of it would not be a rigid body, if you kind of want to think of the difference there. So, if I've got this rigid body on my cube, you'll see when I play the game again, then the cube starts falling. Because suddenly Unity is like, oh my gosh, it has a rigid body, I know what to do with that, I'm supposed to give it gravity. And then also it'll be able to hit other things and, you know, everything along those lines. What if I wanted to have this cube land on something? Can I do that? Well, yeah, actually I can. Just for fun, I'm going to remove the extra stuff here. I'm going to go ahead and create another cube for it to land on. By the way, am I going too fast here, guys? Like, do you think everything's coming across clearly enough that you kind of see where I'm going with it? If not, feel free to just throw in a comment and be like, yo, I need you to explain that again because I didn't really understand it. I don't mind going back and redoing stuff at all. Oh, good? Awesome. Appreciate it, guys. Okay, so I'm going to go ahead and just put this guy at the zeroed out position of this world. And I'm going to go and take this, I'm going to name it like floor or something like that. And I'm just going to go ahead and delete the extra stuff there too, just to prove a point. And that's all. And I'm going to put this floor right beneath the other one, kind of like that. Also, I've managed to do this in the worst possible way. I scaled this the wrong direction. There we go. That looks a little bit nicer, doesn't it? But what is computer? You know, that's a really good question. No, I've got a custom-built computer that David Shemansky, Dusk developer, built for me. That's actually the truth. How do you turn computer on? Depends on computer. Very simple. So we've got something that's going to fall, that cube that we made before. What's that guy doing there? Get out of there. This guy, we've got something for it to fall on, and assumedly, if I was going to go ahead and run this game, we should see this guy fall down and stop right there. So let's go ahead and try that real quick. And of course, you know, to prove a point, the cube falls right through. So why is it falling right through? Well, it kind of goes back to that thing that I said earlier, which is if you don't tell the computer to do something, it's not going to do it. So in this case, what's going on is I haven't told the computer that it's able to collide with anything. David build things. Wow. I know! He's such a talented boy, isn't he? He literally came over to my house one evening with like a whole ton of boxes. It was like, yo, we're gonna do this now. And I'm like, okay, I guess we're doing it now. But it's super nice. So how do we tell the computer that this cube is going to be able to collide with this floor? Well, it's that thing that I deleted. It's called a collider, kind of makes sense. In this case, I'm gonna make that one into a box collider. And you might be able to see, depending on how high quality the stream is, this cube is now kind of surrounded by a green line. And that's Unity telling me, okay, yeah, we've got a collider on this thing. It's going to be able to hit other objects. So now I've got a collider on this cube. Now it should be able to come down and hit the floor and rest right there, right? If I go ahead and play the game, well, it still goes right through the floor. Now, why is that? Pretty simple. I haven't given this thing a collider as well. So if a collision is going to happen, both objects that are inside of this this collision that we're trying to make happen are going to need to have a collider on them. So if I go ahead and put a box collider, again, you can kind of see those green little lines surrounding that object there. If I go ahead and put a box collider on that guy and run the scene again, you'll see, okay, finally, the cube actually hits the floor and everything is good. Here's kind of an interesting thing. What if I didn't put a box collider on my floor? What if I put some other sort of collider on it? Like, let's say, how about a sphere collider? Oh man, that's actually way bigger than I thought it would be. Let's just take that down a little bit. So now we've got this weird sort of thing where we've got a collider that is different in shape than like the box that we're giving the collider to. So what's going to happen? Is it going to obey the visuals or is it going to obey the collider? And if I go ahead and run this, you'll see up here, it might look like it's not touching the ground, but down here inside of our game dev mode, you can see it's resting right on top of the collider, even though it doesn't really look like it is inside of the game. Why is this important? Well, it's one of those things that you should know if things are going wrong. And can be really helpful, but we'll get into that maybe another day. Okay, so I'm going to revert back to a box collider here, just so we have a nice little thing to work with. Box collider. So just to show you again, we've got a cube. Cube can land on floor. Cool. Let's try to move the cube around. Let's make a little bit of a platformer. Right now you can see if I push the arrow keys, not what we expect to happen is going to happen, because I've got scene selected. If I try to do that on my game view up here, you might be able to hear me tapping my keys. It's not doing anything at all. Of course, that's because we haven't told the computer that it is able to move the cube left and right. So this is kind of where things get a little bit messy and a little bit complicated. Movement, or really anything in game design, is not as simple as just doing it. There's always a million different ways that you can go about doing something. And some of them are distinctively better than others, and some of them are better in certain situations, and it's just kind of depends. So I'm going to be showing you guys a way of doing this, and by no means do I think this is the good way of doing it, but it is the most simple way of showing how to do it, and because of that, it'll be the best for this demonstration. If you are trying to make a nice professional product, I would actually strongly recommend against doing movement this way. And later down the line, I will show what I think is a much better way of doing the same thing. But it's much more complicated, so I don't want to start with that. So let's go ahead and go back to our code here for a second. So what we're going to need to do is we're going to need to have a way of telling Unity, hey, we have a cube, and it knows that it can fall, and it knows that it can collide with things. Can we make it move left and right? Well, we can. It's actually pretty easy, but we're going to need to know how to do something else first. So I said before that these things were called functions, and I'm highlighting these letters and these curly brackets all in one because how this works in coding is you've got the name of your function up here. That's like what you call it. Just kind of take that as it is for right now. And then you've got a way of telling the computer with these two brackets where the code for that thing is going to be. So we know what it's named, we know where the code is going to be because I'm telling it with these curly brackets. So if I was like to say I have the curly bracket down here, then we know that it's going to take up this much code, if that kind of makes sense. And then we have a space to actually put the code, which is in between the curly brackets. And you saw me do that before. Well, so that's what a function is. There's another thing in programming called a variable, and a variable is very different from a function, but equally necessary. So in this case, I'm gonna go ahead and just make one, and then I'll tell you what it means. So we'll do public rigid body, my rigid body. Okay, this is pretty simple. In fact, that's a word you've already seen, so you might be able to figure out what this is going to be doing. But we've got this word public. Don't worry about that for right now, but just know that that is necessary for what we're about to do, and I'll explain it in a second. We've got a name of a component that we know is referring to the object falling and moving around and colliding with things. That's interesting. And then we've got some sort of word here, some sort of phrase that I've given it. In fact, I could name this anything I wanted. I could name this, yo, well, not with a comma, I am a mushroom. If you are a mushroom, in which case, you know, that would be true. Or you could say, yo, I am not a mushroom, which I'm assuming is probably more true for the majority of people that are watching this. Suffice to say, though, you can name this anything you want. I prefer to try to name it in such a way that if I was to see just this word, I'd kind of know what it's referring to. That doesn't always happen, but hey, we try. I love giving them names completely irrelevant to what they're actually used for. I know, isn't that the best? And then people like call you up in the middle of the night and be like, dude, where's your variable for such and such? And you're like, I don't know, man. I don't remember what I called it. It was probably called like Sloop-de-Loop or something like that. Call them bad physics. I know, right? Unity rigid bodies are not the best thing in the world by any means. For now, we're just going to stick with a rigid body so everybody knows what we're talking about. But I've now declared this variable. So what does this thing do? Pretty simple. It holds a bit of information. What sort of information? Well, that's what this is telling it. Right now, I'm saying I have this thing called my rigid body, and I'm going to be putting data referring to a rigid body inside of it so that I can access it later and use it later and be able to see what data that is later. Just to kind of show you what I mean, if I was to go back to Unity, and I was to go over to my cube here, and in that cube script right over here, you'll see that there's a little space that says my rigid body. That's what I named that variable before. And there's a space for there to be some data. Just like I was saying, it's a thing that holds data. So if I was going to go ahead and drag my rigid body into there, you'll see it's like, oh yeah, the rigid body on the cube. I know what that is, because I've told it, oh, hey, you know, when I'm referring to my rigid body, I'm referring to the data of this rigid body that I dragged into that space, if that kind of makes sense. So what can I do with that? If I go back to my code here, So now I know whenever I say anything concerning my rigid body inside of my code, we're going to be talking about that thing that is making my cube move and fall and collide with stuff, and, you know, that's the name that I've given those attributes, essentially. So, just to kind of show you what I can do with these sort of things, I'm going to use that print statement again, that printed some words to the screen. But instead of printing just like some basic words like, hey, what up, or anything like that, I'm actually going to print the contents of this variable so that we can see what it's saying. So if I was to say print my rigid body, let's print the velocity. What's this period mean? Don't worry about it. I'll get into that later. But we're going to print the velocity of the rigid body. Velocity being how much it's moving, obviously. And if we kind of come back here and open up that console that we were seeing words appear in earlier, you'll see that we're getting some numbers now. I'll go ahead and just stop it because that's really all we need. It looks like it's starting slow, like a kind of small number, and it gets bigger, and it gets bigger, and then at some point that number just goes to 0 immediately. And if you kind of think about how this cube is falling, oh, that's probably referring to how fast it's going, right? Because that's the velocity. That kind of makes sense. So it's going a little fast, and then it's going faster and faster and faster, just like you'd expect if something was interacting with gravity, and then when it hits the ground, suddenly it's not going anywhere at all. Oh, are you guys talking about physics in the chat? Physics, more like you need to change a lot of settings for it to not feel like moon gravity. I know, right? What I usually do, honestly, is I take a rigid body and I just like completely overwrite all of its velocity calculations and just put my own in. So I still get Unity's collision system, but I get to do whatever the heck I want with the velocity. So anyway, you can kind of see that now we're able to access the data concerning how fast this thing is going. So now it's not just a cube falling, now we know exactly how fast it's falling and when it's falling and everything like that. That's pretty handy. We can start to work with that. Just gonna check a thing here real quick. So, we are able to see how fast our object is falling and when it's falling and things along those lines. And actually, I'm going to go back to Unity real quick. We've also got some other data here that we're not even talking about yet. We've got some zeros that are being printed out next to these numbers that are referring to the gravity and all sorts of stuff like that. Maybe that's going to be referring to our object moving left and right and back and forth. Well, it is. You know, that's exactly what it is. So we don't just have data on this thing falling. That's just that one number there. We also have data about it going left and right, which I happen to know are these zeros on the left. And we have data about it going backwards and forwards, which are these zeros on the right. So how is that useful to us? Why do we care about that? Well, it's not just all about being able to see the data, it's also about being able to manipulate the data. So in this case, let's not just print out the velocity, let's actually set the velocity to something and see what that does. Instead of rigid body.velocity just being a thing, we're going to say that rigid body.velocity is going to equal this thing here, and I'll explain what that is in a little bit. And we'll say 2, 0, and 0. Now this is going to do some really weird stuff, just so you guys know right out of the gate. But you kind of notice, you know, we have 3 numbers being printed out on our console over here. 1, 2, 3 numbers there, and we are putting 1, 2, 3 numbers into this data here. I mean, that kind of makes sense, right? We've got a left and right number, we've got an up and down number, and we've got a back and forth number. So assumedly, if we were able to access all three of these numbers and jiggle with the amounts that we're putting into that, we should be able to move the cube wherever we want, right? So what I would expect to happen in this case is for this cube to move pretty much directly to the right, because we've got a 0 in the up and down and the 0 in the back and forth, but we do have something in the left and right. So let's go see what happens there. If I go ahead and run this, we'll see that our cube kind of goes straight to the right. It's going down a little bit due to Unity wanting to apply gravity to it, but then me also saying, but no, we don't have any gravity. Just ignore that for now. We'll work with that in a little bit here. So, okay, we're able to move it right. That's really good. How would I move it left? Well, if positive is to the right, then negative is to the left, right? It's just flipping the number around so that it goes the other way. So if I was to go back to Unity here real quick with a -2 in that slot instead of a normal 2, you'll see our funny little box goes off to the left. Okay, neat. So we're able to move it left and right, but now it's not really moving up and down at all. So how are we going to do that? Well, let's do a mixture of the two things that we've already done. We've got, excuse me, all the burping. It's from drinking too much water, man. Water is just the worst. So right now we're saying, okay, go left and right, but don't go up and down, and definitely don't go back and forth. So what if we were to say, okay, go left and right, but whatever you were going up and down, just keep doing that. And we kind of already know how to do that because we were printing out that data to the console beforehand, right? We were saying my rigid body and then that period for some reason, and then the velocity. And now I've got another period and I'm saying y. What's that refer to? First thing, out of the many pieces of what the heck is going on here, let's talk about why I would put y in this place, and why I would know that I need to put y in that place. So if we go back to Unity real quick, you'll see that position is being represented by an x value, a y value, and a z value. Man, that really sounds like a graph, doesn't it? Well, that's essentially what all space in game development is really just a 3D graph. And you have these things, and they have positions on your 3D graph, and if you were to like move their position around on the 3D graph, then they're going to move in the game. So you can see I'm adjusting the value of the X position on my graph, essentially, and you see that the box is moving left and right, and if I was to adjust the Y position on my graph, the box moves up and down, and it's a little harder to see, but if I adjust the Z position, my box moves forward and backwards. Stop with your anti-hydration propaganda. Yeah, I know, water's just the worst, man. Everybody needs to just start drinking, like, the nectar from flowers or something like that. We could just become, like, instead of having to worry about the bees dying out, we could just become the bees and just be the bees for the bees. You know what I mean? It's really very simple, I think. Okay, so anyway, we know that X is going to refer to left and right because that's how it works on graphs. Y refers to up and down. Okay, that's not usually how it works on graphs, but that's just how it works in Unity graph language, so don't worry about it too much. And then Z is back and forth, and that's also a little different from normal graphs, but that's just how it works here. I only drink fresh rainwater that I catch on my skin. You know, that's like, you know those super expensive bottles of water that are like crystal water from crystal streams? That's like that, but times 10. It's not just about having the purest water, it's having the purest water in the purest fashion. So, anyhow, when I'm referring to up and down, then I always know I'm going to be referring to Y, because that's just how movement works inside of the world of game development, right? So that's how I know when I want to keep my my gravity going, I'm going to need to refer to Y. Okay, cool. So we've got a -2 here. We always know that's going to be moving to the left. And I'm saying whatever the heck you were doing before, your rigid body Y velocity, just keep doing that, man. And never move back and forth, because we all know that 3D games are the worst thing ever, says the 3D game developer. So if we go ahead and run the game here, you'll see that it... Oh, wow. I was not expecting it to do that. That's actually super cute. Look at it go. Hold on, wait a minute. This is way, way, way too good of a situation. We've got to capitalize on this. If we go ahead and rotate this guy and make a little ramp for him, do you think he'll like roll down the ramp or something like that? Let's go ahead and attach the... Oh, this is going to be so sickening! Oh, watch this! Watch this! Ready? Ready, ready, ready? Womp, womp, womp! Oh, that's the best. I love it. Okay, I'll talk about how I did that here in a second. I just wanted to do that, because I saw an opportunity and I had to take it. Oh my gosh, what do you think happens if we... Wait. One further experiment needs to happen here. We need to give this thing a sphere collider. This is gonna be so sickening. Hopefully. Nice. Okay. I'm good. I had my fun. Anyhow, back to our coding. Right, so it obviously still had gravity, and it still had this whole thing where it goes directly to the left. Cool. So it seems like we're able to move our box, to some degree at least. But it's just moving on its own. So how do we get it so that it only moves when we want it to move? Well, we're going to need to learn a little bit about what an if statement is. Again, this is going to be one of those things that I'm not going to do this in the way that I would like recommend a professional game developer do it. But this is a very simple and easy to understand way to do it, so I'll do it that way. Yeah, aren't if statements the best? Although, I will say, if I was going to choose between them, I think I like switch statements better. Cause like, okay, story time. Back in college, my my computer science professor, just so you have a little visual, is like a statement. Oh, sure, whatever. So there's this thing called a switch statement for anyone that doesn't know, and it's essentially like a bunch of if statements put together. Just ignore kind of all the red lines, do a thing, right? So you can kind of do this, but then you can say, well, but if it's something else, second case, you know, then do something else. And so my professor in college was like, yo, there is no reason to ever do this and not just have it quit out of whatever it's doing as soon as it's done. So like in other languages, you're able to take these statements out. So if it says, oh yeah, it's equal to 1, I should do this, it'll do this, and then it'll fall down and do this, and then it'll fall down and do this, and then this, and then this, and then this, and so on and so on and so on. So during one of my assignments, I was like, he can't be right about this. There has to be a way to use this legitimately, this sort of weird functionality. And I found a perfect use case for it, and I was so proud of it, and I was expecting his mind to be blown, and he didn't even say anything about it. I was like, what the heck, man? No, I like did so much extra work trying to find a good use case for this thing. Ugh. Anyway, that's why I like switch statements. But what's an if statement? Let's talk about that first. Well, remember how we're able to like access the data of something? Excuse me. Before I go into this, I'm gonna go get some more slurping water. I'll be right back. Or just be a hipster and use ternary operators. Yeah, you could do that. Okay, I'm back. I've got my water. I'm ready to talk if statements. So we're able to access the data coming from a variable. We printed it to the screen. We're using it to say, hey, yeah, keep doing your gravity thing. We can also check to see if that data is something. With these things called an if statement, you can see it's highlighted in blue, so the computer's like, oh, yeah, I think I recognize that. Slurp, slurp, slurp. So how does this work? Well, let's say that I wanted to see if my... we already know what myRigidBody.velocity.y is doing. That's getting us the up and down of our cube. Let's go ahead and see if that up and down is super fast. Let's just print a word to the console so that we can see it. So if it's like below -5, believe it or not, below -5 is equally as fast as above +5, because this is just going down really fast instead of going up really fast. But if it's below that, then let's just, whoops, using the simpler one. Let's just say, yeah, it really is really fast. It is really fast. And we'll be able to see that word print. So I'm actually gonna remove this floor here for the moment, because I don't know how long it's gonna take for it to do that. But if I go ahead and play and open up that console there, it's pretty quickly, it's like, yeah, that's actually going really fast. Actually, that's a horrible demonstration because it just looks like it's doing that from the beginning. Hold on, let's think of a better one here. Tell you what, let's just use a button press. That's where we were going anyway. Let's just do it, right? Get key down. So if we're gonna punch a key, let's say that I'm punching E. And then it's going to be like, yeah, it was really fast. Not because the cube is moving really fast, but because I have secretly written a bunch of code for the computer to determine that me pressing the key is happening very quickly, and it's congratulating me for that. So I'm going to go back to Unity here. Our poor little cube can do his whole roly thing all he wants. But while he's doing that, I am going to hold my keyboard up to the microphone so you can hear. And I'm going to press the E key, and you can see as soon as I press that, I get that little message down at the bottom, and I can keep doing it, and it keeps doing it down there too. Okay, neat. So I'm able to get a key press, and when I do that key press, I'm able to do a thing, right? You might notice that I have a little indent here. Do I need that? Well, actually, no, I don't. It just looks a lot prettier, so you can kind of tell what's going on a little bit easier. Making Vidya and UE4 taught me how maths actually work. I know, right? Like, you think you know all this about math, and then it's like, oh yeah, find a directional vector, and you're like, wait, how would I do that? I don't mind Unreal 4. I feel like it's really good for large projects, and I just don't really work on large projects a lot, so I tend to use Unity more myself. But, I mean, I think it's still a really good engine. Okay, so we can respond to a key press, because we're saying if that key is being pressed, then print this thing, right? Or before we had if the velocity was lower than a certain amount, then do a thing. But it was kind of hard to see that working, so we switched over to this. Okay, well that's kind of nice. Let's see what else we can do with this. Let's keep with the key code sort of thing going on here, and let's say, well, what happens when we press A? That's when we want it to move to the left, right? So actually, let's switch it up so that it does that. So when we press A, our box is going to move to the left and no other time. Let's just get rid of that for a moment. Unity doesn't have visual scripting or writing actual code is hard, so oh boy, I'm gonna stay out of the comments for a little while. They are actually adding visual scripting to Unity soon, and there are plugins to do it. You know, you want to know something though, and this is coming from an old foggy person that started without visual scripting doing his game development. I don't think it's nearly as easy to do visual scripting in the long run. It's super easy right up front, but as soon as you get into anything complicated, it gets a lot more visually confusing, and it's, at least in my opinion, it takes a lot longer to do it. That's not saying that that's not the case for everyone, or that's not saying that that is the case for everyone, but definitely for me, I prefer code like this because it's just a little bit more compact, you know? Anyhoozle. So what am I going to do over here? I'm going to create a number. And how do I create a number? Well, there's a word called an integer. You might remember that from your maths class. But we're going to use that to move our character around. We'll call that move speed. Move speed X, because we know we're going to be moving left and right. Why am I doing this? Well, we'll see in a second here. Once again, by the way, for the seasoned coders in the chat, I know there's better ways of doing this. This is going to be really disgusting, but it's the easy way of doing it, so don't worry. So move speed X is equal to 0, meaning we're not going to move. But if we are pressing a key, well, we should move, right? So we could say move speed X is equal to -2. That's that number that we've been having down here, right? So instead of just having a -2, now what we can do is we can say move to the left and right whatever this thing called move speed X is. So it might be 0, but if we're pressing A, then it's going to be -2, which is just the same number that we had before, right? So let's go see what happens there. If we go ahead and play the game here, and I'm holding my keyboard up so you can hear when I press the A key, oh hey, it does kind of move. It's just really slow. Womp 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 womp. You can kind of hear me pressing and see the cube moving a little bit. So why is it doing that? I don't quite understand. Says the people in the crowd, and I say, worry not, for the answer is simple. This is looking for when I press the key down. This isn't looking for while the key is being pressed for the entire time. Meaning what's going to happen is this is going to come in one frame. It's going to see, oh yeah, the key's down. Make it -2. And then it'll come back the next frame and be like, well, make it 0. Oh my gosh, the key's not pressed. Don't do anything there. And we don't move ever after. So how do we change that? Pretty simple. We just say if the key, which is a weird way of saying it, but that's how Unity does it. So now, instead of just looking for when I press the key, it's going to look for every single time that key is being pressed down. So if we go back to Unity here, you'll see now when I press and hold the key, my cube starts doing what it did before. Whee! That's so cute. Okay, cool. So we've got it moving to the right. You might even be able to guess what we're going to do next. We're going to make it move to, or we got it moving to the left. We're going to make it move to the right now. And that's pretty simple. We're just going to add another phrase that looks very similar to the one that we did before. But in this case, we're going to have the D key being pressed, and we're going to set this to +2 instead of -2. So when I'm pressing the A key, we've got a negative move speed. When I'm pressing the D key, we have a positive move speed, and we're going to move by that move speed. So let's go ahead and see what happens here. So I come in, I'm holding the left key right now, I can move to the left. I'm holding the right key right now, and I can move to the right. And that's pretty good. That's pretty much what we're looking for. Now, of course, there's a lot that we need to address, such as the fact that the cube can kind of balance on its edge and stuff like that. But we've got the basics going on here. And even if I was going to walk off of the edge here, hey, he even falls correctly and everything like that. Neat. We're super close to having a tiny little game put together. I'm really digging the way this cube boy moves. I know, it's kind of like clomp, 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 clomp. It's great. You know, so we're close enough to being able to have a game that we can play. Let's just go ahead and do the extra bit and get it to the point where we'd be able to make the cube jump and maybe make the camera move along with the cube. And both of those things are pretty easy. So let's go ahead and do that right now. After taking a sip of water out of our fancy Frosty the Snowman cup. Okay, so we've got a key press for A, we've got a key press for D. Let's do a key press for space. If input.get key, and we're going to do get key down this time because I only really want this to happen when I press the space bar, right? Key code dot space noise. And before we stop here, I'm also going to tell you guys what these dots mean because I've kind of been holding that over your head for a little while here. Okay, so what do we want to do to make this guy jump? How are we going to do that? Well, we already know that he's able to move up and down. That's what this thing was doing, right? And we already know that I can assign velocities, right? Because I'm doing that here. So maybe what I could do is I could just write another one of these statements, but instead of saying, hey, yeah, take whatever your up and down movement was and just keep doing that, maybe we'll just say, no, we don't want you to keep your up and down movement. We want your up and down movement to go up because we're jumping, right? So let's go ahead and just copy that for a second, paste that in here. And we know, oh, I should have copied the whole thing. So we're gonna set our velocity here, just like we did before, just like we did down here. And put that in. By the way, you need to have these guys at the end of every line that you write, or else the computer is like, hold on a moment, I don't know what we're doing here. That's why we put these guys in. It's just the thing you do. Don't put them after if statements, put them after like everything else. I don't know. It's something from how the compiler works and stuff. You don't need to worry about it. So anyway, so when we press the space button, do the exact same thing that we're doing down here. No, that's not what we want to do. We want to make sure that we go up, and up is a positive number. So let's just put in an arbitrarily high positive number. So every time I press the space key, then we're going to set to an arbitrarily high positive number. And just so you guys can see it too, this is being set to whatever our movement key is right now, and that would totally work in like this simple situation. But in general, just to be safe, we're just going to go ahead and say, no, we're going to set to whatever the heck your left and right movement is. We don't know what it is. We don't care about move speed X. We're just saying whatever it is, just keep doing that. And you know what? While we're at it, whatever your front and back, going front and back velocity is, just keep doing that too. All we want to change is just that jump, right? So if I go back out here, and I go ahead and play this, we can still move, and if we press the space key, hey, that kind of looks like a jump. Am I able to jump in midair? I absolutely am able to, because we haven't told the computer that you can't jump in midair. But maybe I'll save that for another day, because that one's a little bit more complicated. But for right now, we're able to move around, we're able to jump. As far as I'm concerned, all we really need to do here is get that camera to move along with the player, and maybe get some platforms in here, and we should be pretty good. So real quick, let's go ahead and, where's my scene? There's my scene. Go ahead and create another cube. And I know I can copy and paste that, but just want to do it this way. And we're gonna drag that over here. Notice I can't see it on my game screen, but I can see it down here. That's why this screen is so important. I'm even going to scale it a little bit. You can see that I'm scaling it along the left and right value. So that's getting bigger. I'm going to put it over there, so that gives me something I can jump to. So the last thing is we're going to want to get this camera to move to where my player is. Well, we kind of saw before that maybe that's not just so simple as just dragging it beneath the cube, which, by the way, will mean anytime I move the cube, the camera would move with it, which seems in practice like it would be perfect for what we want to do. But it doesn't really work out that way because our cube rotates, which is kind of a helpful little accident, isn't it? And that just looks not... I mean, it would be cute in very certain circumstances, but maybe not here. So let's do something a little bit different and maybe a little bit more complicated, but it'll just take a second. Remember how we're able to make our own scripts? We can... actually, I'm going to show you the better way. We're in our scripts folder down here. I'm going to right-click, and it brings up a menu that has Create at the top, and if I bring that over, it has C# script. There, I wish I could show that to you guys, but it doesn't show it on the stream. But essentially, I click that, you can see that it's given me a new script. I'm just going to call this the camera follow. And now, we are able to search for camera follow over here in our little drop-down menu and add that on the side over here. So now, we would expect the camera to follow, but of course it's not going to because we haven't told it to yet. So I'm going to go ahead and double click that script that I just made and transition over here. And so this is actually going to be pretty simple. We're going to be using the same concepts that we already have been using, just maybe in a little bit of a different way. We're going to make another variable. Public, by the way, just means that the Unity inspector tab over here, let me just show that to you real quick. Unity Inspector tab over here is able to see that variable. So you'll kind of see in a second. Right now, it can't see it. But if I go over here and I put public and, oh, what's a game object? Well, I'll talk about that in a second. My follow point. If I was to say public game object, my follow point, and go back to Unity, you'll see that that pops up there. Oh, there's my follow point, and that's because it's public. Public is a little bit more nuanced than that, but for the moment, that's really all you'd need to know. And I'm just going to go back to my code real quick. And so every frame of the game, so in update here, I'm going to want to move this camera to this object. I'm going to put the cube into this place here. That's what oh, I should explain this. I'm sorry. What's a game object? A game object is literally anything that appears in your game. It has something to do with this word here, but you don't really need to worry about exactly what it has to do with this word, but just everything that you put in your game is going to have a game object. It's just like saying, oh yeah, it's in the game, and we can like access that data and use it. We know what it is. So in other words, I'm going to put my cube, my player, into this data here so that I can access some data about my player, specifically where my player is, so that I can move my camera to that point. So every frame of the game, move my camera to wherever the heck this is, right? That's pretty easy. Transform.position is equal to my follow point dot transform.position. What's transform? Oh, it's just like exactly, it's exactly what you think it is. It's just your position and your rotation and your scale. You might remember right at the beginning of the session here, we looked at that as our first component that we looked at. It's called a transform. It's got position, rotation, and scale. I'm just accessing it in code, and you can do that by just typing the word transform. So the position of my game object that this component is on is going to be equal to the position of that game object. Well, that seems like that's pretty much what we want, right? If we put this script on the camera, then it should just move to that game object every single frame, and we should have a moving camera, and we should be all good, right? First thing we're going to need to do real quick before this is going to work is we're going to need to tell the camera that it should be following the player. So we're just going to take the player, which is still named cube. Let's just rename that real quick. So we're going to take the player, and we're going to drag it into that slot over here. And now if I play my game, you're going to see that chaos abounds. What on earth is going on here? Well, if we go into our scene, you can kind of see it is working. And if I was to move my player around, you'll see that the camera does move with him. But it's just too close. It's just not quite right, because it's right on the player, and so the viewport is going right past everything. Yeah, you became the cube, right? Which might work if you were trying to do a first-person game, but that's not really quite what we want right here. So how are we going to work with this? Well, we know that the camera needs to be more like out here for it to work, right? Or else if we get closer, it's going to look like that, which is what just happened. So if we kind of go in here and start looking at the values, we'll see, okay, as I get closer, that means that Z is going to get more and more positive. Meaning if I had just a consistently negative Z, then it should always be looking at the player like that, right? Oh, okay, well we know how to do that. That's pretty easy. All we need to do is just create another one of those 3 sets of number sort of things and use that guy instead. I'll talk about exactly what this statement and what all these parentheses mean some other day. But what we can do here is we can say my follow point dot transform dot position dot x. That's a lot of words, but I mean it's just that game object, where it's located, that's the transform.position, and specifically the x. And then we're going to do my follow point.transform.position.y. So we know that we're going to be going to the x, we know that we're going to be going to the y, and just always have a negative z. Just like we were showing over in the Unity window over there. So if we kind of go back to Unity and try playing the game after we've written that, you'll see, oh hey, that seems to work pretty well actually. I'm able to move back and forth and the camera follows me pretty exactly. Am I able to jump over this pit? Yeah, if I jump again in midair. Maybe this isn't the best designed game, but it is a game, and that's the point. So real quick, I want to talk about what those periods are back in code. And then I think that'll probably be where we leave off for today, just so that I don't kind of overload information all at once. But what are those periods? Okay, well, you might have kind of guessed it from us using this transform.position.x sort of thing, but some pieces of data have more than one piece of data inside of them. Like, for instance, this transform, when I'm getting like the transform data of my object, you can see, oh wow, you know, we've got position and rotation and scale. That's more than one piece of data. That's actually more like 9 pieces of data. Well, it still holds all of that data, but we just need to be able to access it, right? So in this case, what we're saying is, oh, hey, we know that we've got the transform. We know that there's a position thing in that transform, and we know that that position thing has an X value inside of it. And so we just use periods to get at more specific bits of data. So for instance, I can kind of show you along in the Unity window here. We know that a game object, like my cube here, has a transform inside of it. This dev stream isn't accurate. You haven't taken a Twitter break yet. You know, tell you what, I'll take a Twitter break before I end the stream. How's that? Dang, I missed most of the stream. I'll have to start it over on the weekend. Oh yeah, man, sorry that you missed it. But no, the VOD will still be on Twitch for sure, and I also always upload stuff to my YouTube channel, so you can totally grab it either of those 2 places. But anyway, so we know that game object, the cube that I was dragging back and forth, has a transform. And we know that that transform up here has a position right there. And just going back to the code. And we know that that position has an X value. You can kind of see that over here, we know that that position has an X value. So we are just using those periods to get at more accurate and more accurate and more accurate data as we go along. This is getting to the subject of object-oriented programming. That sounds like kind of complicated, but at the end of the day, it's actually kind of simple. Object-oriented programming is just bits of data that have multiple pieces of data underneath them, just like we have with this game object has a transform, has a position, has an X value sort of a thing.